All right, I did a video yesterday on this I2C sniffer. It interrogates the bus and sees what devices are on the I2C. So it goes through all of the different addresses and see what's out there. And it finds two devices, one at 3C and one at 60. 3C is the actual I2C address for this display, and 60 is this little chip over here. And so it's doing that. Well, how does it do that? Okay, so we're going to be taking a look at some bus signals on the I2C to see how this thing actually functions. Okay. All right, so we have clock and we have data, S clock and S data on I2C, and I have protocol decoding on, and so it's sending something to address. Here, let me stop it. It's sending an address out. So the controller sends an address out. It says, hey, I'm going to send 3C out on the bus, and I'm going to say, it's going to be a write command, okay? And so all of the devices out on the bus are listening all the time. And when you hear your name called, 3C, you say, oh, that message is for me. And it means that somebody's going to write to me. If it's a different bit there, that bit is either a 1 or a 0. And if it's the opposite state, it says, I'm requesting you to send me data. I'm requesting a read. And then whatever device is out there will send data, okay? And then the device that's listening all the time, okay, hears its name, sees that it wants to be written to, and then the controller lets loose of the bus. And then the device at 3C acknowledges that. It pulls the line down and says, I heard you, I heard my name called, I know you want to write to me, that's okay, I'm going to acknowledge that, okay? And then it sends some data, the controller sends some data, and then the little chip that's receiving says, yep, I got it. And then it sends another 8 bits, and it says, yep, I got it, all right? And so everybody's handshaking on the same open collector line, all right? So we're going to look at some things here. How does it know whether a device is out there or not, okay? So what I'm going to do is I'm going to trigger, right now I'm triggering on 3C, but we're going to set it to trigger on address 59, okay? Hexadecimal 59. All right. And so this is what gets sent out. And it's doing that every couple seconds. It's doing a poll of all addresses every few seconds. So again, the controller takes control of the bus, it pulls this down, and then it starts sending clock and data, and it sends out a name. It sends out 59. It says, hey, 59, I'm going to write to you. And then there's no 59 out there, and nobody hears it. And so nobody sends an acknowledge signal. And so that's decoded as a NAC, no acknowledge, okay? So there was no acknowledge, which means that nobody was listening, there's nobody there, right? And so we can say confidently that there is no device on the bus that has address 59, all right? So then let's do a trigger on address 60. Now, once again, the controller sends out 60. I'm going to write to you. And guess what? Somebody heard their name called and says, yep, I acknowledge you, I'm here. And so we know that there is a device out at address 60. And nothing else has to happen. The only thing that little chip has to do is pull that line down. You know there's something there, so you go to the next one. You say, okay, was nothing at 59. Hey, there's something at 60. How about 61? And so we go here to 61. And once again, no acknowledge, so there's nobody at 61. And then it goes through all of the addresses, okay? It's 7 bits worth, it's not 8 bits worth, but it's 7 bits worth of address space. And it goes through them all right? So what about 3C? Now 3C, multiple things can happen. We can be told to write, because remember, the little board here is displaying information, so we're always talking to the display, all right? And so some of the times we get this thing here says, oh, we're gonna, let me stop this one. We're gonna send you some data. We're gonna write to you, okay. And then we send the data and it says, okay, I got it. And we send the data, okay, got it, right? Sometimes it's just this. It's just the device polling. It's going all the way around. It gets to address 3C, and somebody heard their name called, and whack, they hit the acknowledge. And then the little program, the for next loop in the program says, oh, there's somebody at 3C. All right, so some of the times 3C is just, hey, I'm here. And then the rest of the program actually uses 3C to display data and stuff. So that's why sometimes you see stuff, and sometimes you don't see stuff, okay? Let's move this over here. Sometimes it's writing a whole bunch of stuff to the display, right? Let's stop this one here. So 3C, yep, I'm here. Here's a bunch of data. Ack. Yep, I got it all. All right, let's look at that little program here. We're going to include a library for talking to the OLED display. We're going to include a particular font that I like, a little bit bigger font, easier to read. And then we're going to come down, we're going to turn on the display, we're going to display a splash screen. And then here's the loop. We're going to scan the bus, and then we're going to display the results. And then we're going to wait 2 seconds and then do it again. So we're going to go around this loop every 2 seconds. Scan the bus, display it. Okay, so here's how you scan the bus. You're going to start out with, we haven't counted anybody yet, 0. And then we're going to go between address 8 and 119. And we're going to send the address onto the I2C bus. That's what this does. Wire begin transmission address. So it's going to put that address out there. And then it's going to look to see if it got an ACK. If it didn't, it's going to flag. If error, this flag that comes out of the end transmission, if the error is 0, then the device acknowledged. Otherwise, the device count, see your device count less than 16, found address, device increased the count. All right. So let's see, why is that in there? The AI wrote this, not me. If the device count is less than 16, okay. Then it says you found it. So I guess it can only count up to 16, something like that. Anyway, so it's going to go round, round, and round for each address to see if something came back, to see if that flag got set or not set. Then we're going to display the results. Clear the display, set the cursor, say there was no devices, otherwise it's going to find something. No devices found. Otherwise, it's going to actually display. That's what we saw. It's going to set top of the screen. It's going to say we have I2C devices. And it's going to print them out. It's going to put a 0x to show that it's a hexadecimal, but it's going to print out the ones that it found. And then we're going to go back to the top and then just replace that top line with how many devices were actually there. So at the very bottom here, it says show count. So it says devices, you had so many devices that were found. In our case, it found 2. Anyway, there you go. It's a very simple little program. And the key here is that you throw the address out. That's this line. And then look for an acknowledge, which is this line. So really these two lines are really the whole thing. Either you get an acknowledge or you don't get an acknowledge.